Wait. Are we back in school? Hello everyone, Mr. A here. Today I'm going to teach you a little bit about fractions. So this part is mostly just for my current students. For those of you looking for information on things that can help you, extra practice, our assignments and warm-ups for the week, you can just go here and that's where you can find everything. And to get to the YouTube video, you're kind of already here, but it's on there as well. So just to kind of get started, I'm gonna do some easy stuff. If you wanna work this out on your own, go ahead and pause now. All right, time's up. Anyways, for this stuff, it's really basic. All you really have to do is add your numerators and ignore the denominator. This over here, the bottom number, that's your denominator. Your top number, that's called your numerator. In our case, all we really want to do, as long as we have common denominators, that means the same number, you really just add the top numbers and carry over the bottom number. So in this case, we have 2/3 plus 5/3. We're going to go ahead and combine that, and that's going to give us a total of 7/3. Now, to change this into a proper fraction or a mixed number, it's simply a matter of seeing how many times your denominator goes into your numerator. For example, I know that I can fit 3 inside of 7 2 times. Or another way to think of it is how many times can I subtract this number from my numerator. In this case, I can do 7 minus 3 twice. So 7 minus 3 2 times. I keep the same denominator. That's going to leave me with 1. If I do 7 minus 3, that gives me 4. Minus 3 again, that gives me 1. So I'm going to take that one leftover number that I can't subtract and put it up here in the numerator, giving my final answer as 2 1/3. But let me go a little bit further. In letter A, we have 1/9 plus 5/9. Well, once again, you're just going to add your numerators and keep your denominator. In this case, you come out to 6/9. Now, in this particular worksheet, it happens to be a puzzle sheet, so my students can check their answers to see if it's an answer choice. However, with this one, it's not in its simplest form, so they're not going to find this number. 6/9, while it is a proper fraction, is not in simplest form. Before we can do that, we actually have to think about what two numbers can we divide these by. In our case, the only number we can safely divide both of those numbers by evenly, other than 1, is 3. So I'm going to do 6 divided by 3 and 9 divided by 3. And that's going to give me a new fraction of 2/3, which would be my best final answer. Now, a lot of people get thrown off by fractions, even though you could be adding common denominators or subtracting common denominators. One thing I like to show my students is this little example. And I use this primarily to help out with algebra concepts, but I find it also tends to help with fractions. If you think of these as simply words and not actually the fractions themselves, it changes the problem. For example, if I ask you what 1 apple plus 1 apple is, it's going to give you 2 apples. If I ask you what 2 pens plus 3 pens are, you're going to tell me that there are now 5 pens. And if I ask you 2/7 plus 3/7, you'll probably, as long as I mention it simply in terms of words, be able to tell me that it is 5/7. You didn't see the fraction. You didn't see us actually writing 2/7 plus 3/7, but you can visualize it when you see it written in words. It becomes more handy when you start dealing with algebra, in which case I don't tell my students that it's the letter. I spell out the word X as best as I can and get them to write this down. And then when I write this example down below, it tends to help. But I digress. Let's get back to the fractions. If I take 15/16 and subtract 3/16, well, it's really the same process as it was before. I'm going to take 15/16 and take away 3. That's going to leave me 12/16, but we're not done yet. We have to take that 12/16 and figure out if we can simplify that. Now, a lot of times students will start small before making the big leap. So while there is one number, I can divide both of these numbers now and end the problem. I'm going to show you the slower and step-by-step way. So we take 12 and 16 and we divide it by the smallest number we can think of other than 1. In this case, 2. So I do 12 divided by 2, and that gives me 6. 16 divided by 6, or divided by 2, gives me 8. Now all I really have to do is take that and divide it once more by 2, because again, that's the smallest number I can see other than 1 that I could divide them by. And that will lead me to my real final answer of 3/4. And it's just as effective if you simply started by saying you can divide these numbers by 4. 12 divided by 4 gives me 3. 16 divided by 4 gives me 4. But this is too easy. You don't want the easy stuff. You want me to get to the hard stuff so that way you feel a little bit more prepared for what your teacher might be giving you, or, if you're my student, what I might be giving you. In this case, I gave my students this, which was a sheet that, for the most part, dealt with uncommon denominators, with this one being the exception. However, since they've seen it, and given the fact that many of them are probably going to be watching this, I'm going to give you guys a different one. This sheet right here. These are all addition problems. All of them, or most of them, have uncommon denominators. If you would like, feel free to pause your video right about here, so that way you can see all of these problems, and if you would like to get extra practice on your own, you can. Okay, that's plenty of time to pause it. If you haven't paused it by now, start rewinding and pause it then. And just so that way you aren't going to cheat and your parents told you to watch this and to work out these things and you're going to cheat, watch the whole thing, I'm not going over all of them. We'll start with letter D. For this one, we have 1/2 plus 3/5. Now, the first thing we have to do is we have to find a number that we can divide both 2 and 5 by. Well, the best method is to count by one of those numbers, typically the smallest number, until you reach a number that works. In our case, we'll count by 2s. 2, 4, 6, 8, 10. 10 is the number. 10 is the number that we can divide both 2 and 5 by. So for here, we're going to write off to the side next to our current fraction, we will write our new denominators, which is 10. Next, we're going to change our numerators based on what number we would have had to multiply by. In this case, we would have to multiply 5 by 2 in order to get 10. Since we multiplied the bottom number by 2, we therefore must multiply the top number by 2. So 3 times 2 will give us 6. We'll write that in. And now for our next fraction. We would have had to multiply our denominator by 5 in order to get 10. So now we must also multiply our top number, or our numerator, by 5. And that's going to give me 5. Now I can go ahead and add them together. I take 5/10 and 6/10, combine them to give me 11/10. As we discussed before, we can take that number and change it into a mixed number, simply by asking what 11 minus 10 is going to give me. Well, since I can subtract it once, I know that my whole number is going to be 1. I also know that my denominator hasn't changed. I also finally know that 11 minus 10 will give me one number left over. So I'm going to take that 1 and put it in my numerator, leaving my final answer to be 1 whole and 1/10. Next up, let's move on over to number or letter C. For letter C, this one's not going to turn into a mixed number. If we look here, we have a 3 and a 9. Now, a lot of students automatically, much like this problem, only it would have worked here, will just multiply their denominators to try to find a common number. And while that will work every single time, it often leads to requiring more work than was necessary. For example, for this problem, you could multiply 3 times 9 and get 27, meaning your new denominator would be 27, so you would have to multiply each of those fractions out, and later you would almost certainly have to simplify because, frankly, 27 is not the least common denominator. It's a few numbers higher. So, what you could do instead is that method I mentioned before. Count by the lowest number. In our case, it is 3. When you count by 3s, you'll notice something around the third number. 3, 6, 9. Well, 9 is this number, and frankly, I can do 9 divided by 9 and 9 divided by 3. That means this is my lowest common denominator. I don't have to find any other number. I don't have to continue counting. So when I rewrite my numbers, I'm not actually going to change my bottom fraction at all. It already is the common denominator. The only one that needs changing is my top fraction, 2/3. Now, since I would have to multiply 3 by 3 to get 9, I also have to multiply my top by 3, which is going to give me 6. Finally, I take these fractions and I add them together. 6/9 plus 1/9 is going to give me 7/9, which incidentally is already in simplest form. 7/9 cannot be simplified, seeing as 7 is a prime number and is not a factor of 9. The only factor they share is 1. And that's really about it for adding fractions, and subtracting is pretty much the same exact thing as well. I'm going to scroll down to another page that deals with some subtraction. No, I'm not. Now this page I have already assigned to students for homework. But if you're not one of my students, or if you're one of my students who I did not assign certain questions to, you already have this worksheet, go finish it. But everybody else, let me show you a few things. For the most part, at this level, you will not be expected to subtract negative fractions. Your answers generally will not turn into negatives. Now, if you are a 7th grade or 8th grade viewer, you very well may be expected to do that, and you really should go speak with your teacher about that. But anyways, looking at this, you see that, for the most part, barring this one, they are all uncommon denominators, but the process remains the same. In this example, you can see that 5 and 10 are both the denominators. Well, if you keep in mind that counting by 5s, the very second number is going to be 10. Their common denominator is not 50, it is 10. So, you write off to the side your new denominator, which is 10. Your new numerator, which multiplied by 2 will be 4. Your old fraction is rewritten, and you simply do 9/10 minus 4/10, which gives you a total of 5/10. Now, unlike the other page that we were just on, this fraction is not yet in simplest form, but is also not going to be rewritten as a mixed number. This number is actually going to be simplified because, as we discussed a moment ago, 5 is a factor of 10. Therefore, I can simply divide the numerator and denominator by 5, and that will give me my new fraction. Incidentally, if you want to take a shortcut and are familiar with this, 5 is half of 10. Therefore, your new fraction is just going to be 1/2. And that really is the same process for everything else in subtracting fractions. There's not that much more to it. And that's pretty much it. There isn't that much more to adding and subtracting fractions, unless you get into adding and subtracting mixed numbers. In which case, the only real difference you're going to have is, well, converting them first. So I suppose before I go, I'll show you that too. So let's say, for example, I have 3 2/5 as one of the fractions that I am dealing with. This method will work for just about every single mixed number there is. All you really have to do is throw an uppercut punch. Okay, well, let me back up a second. So I've done martial arts for a long time, and more or less I equate this to throwing an uppercut punch, which is that to throw a good uppercut punch, all you really have to do is start in the middle. So you're starting with this 3, the number in the middle. At this point, you're going to actually have to drop your fist a little bit, because if you're throwing an uppercut, your fist has to come from below. Otherwise, it's just a regular punch. So you start off by taking this 3 and you're bringing it down. Now, when you bring it down here, you're multiplying. I don't really have a good analogy for this, but you are dropping the 3 down and multiplying it. So we're going to take 3 times 5. That's your drop. You're getting ready. 3 times 5, of course, we all know is 15. You're then going to take that number, that 15 that you just got, and you're going to add it to the top. So the whole motion is going to look similar to an uppercut punch. You're going to drop and do an uppercut. I know that looked cheesy, so stop laughing. Once you have added that 15 to the numerator, you come up with 17. Your denominator, much like with adding and subtracting fractions, is not really going to change at all. This number, 3 times 5 gives me 15 plus 2, gives me my new numerator, while my denominator stays the same. Once you have converted this fraction into an improper fraction, adding and subtracting fractions, as well as multiplying and dividing them, becomes a whole lot easier. So what I'm going to do is I'm going to put up one more page with a bunch of examples kind of like this. And if you would like, you can pause the video on the next screen and start working them out. Okay, here are the fractions. Feel free to pause the video now and go ahead and record them. Work them out at your own pace and, well, just pause the video right here. Okay, assuming it's paused, or assuming that you are done, I'm going to go ahead and flash the answers on the board now. The answer to this one is going to be 1 and 5/6. The reason these two fractions change their denominators is because this one and this one each have a common denominator in 6. That is, counting by 2s, 2, 4, 6. Counting by 3s, 3, 6. I see the common denominator simply at the second number. I rewrote number 2 a little bit better just so that way it seemed more familiar. Stacking them vertically, one off top of the other, I had 5/4 minus 1/2. I changed to a common denominator, and then I simply subtracted. 5/4 minus 2/4, 3/4. Yeah, number 3 was pretty easy. Really, it's just 2 plus 1/4. Well, that means it's just going to be 2 and 1/4. Kind of straightforward there. All right, I definitely did not make number 4 easy for you, but that's kind of the point. Number 4, it's the last problem. It's supposed to be a little bit more difficult. Here, you had to convert 5 1/5 and 4 1/3 to improper fractions. And frankly, that is no easy feat. That's going to give you 26/5 and 13/3. And then you have to change those so that they have a common denominator, which is 78/15 and 65/15. Finally, you take those two fractions and subtract them, and you come out to 13/15. Now luckily, because this one had the lowest common denominator, our numbers weren't any higher than this. But imagine if we had kept going and used 30 instead. These numbers could have been twice what they were, and then we still would have had to simplify at the end. That's the importance of trying to find the lowest common denominator rather than simply picking whatever number they happen to have in common.
Hey guys, sorry. Thing cut out, I don't know why. I'll work on fixing that in a bit, but in the meantime, here's the selfie cam for me to just finish up and say, go practice on your own, and that's it. It's late, I'm tired, I'm frustrated that my recording didn't work, so yeah. This is Mr. A. Have a nice night.